Okay, we're going to guide you through another exercise, the likes of which we've already looked at in class. We're going to go to GeoGebra, okay, and in this exercise we're going to look at the angle bisector and using the angle bisector to find, okay, the what's called the in-center, okay. So again, like before, we're going to go to our menu item, to our view. We're going to make sure our algebra menu is on, our graphics menu on, and our input bar is on. I'm going to do away with my axes for this exercise. Okay. If we need to construct an angle, please know by definition, angle is a union of two rays with a common endpoint. So I picked up my ray tool. I'm drawing a ray here, common endpoint being A, and I'm drawing a ray here. Okay, so there's my angle, and my angle is indeed flexible, if you will, because I can pull on it and I can change the size of the angle. If we're asking what is the size of the angle, then I need to measure it. Again, to measure the angle, I need to go to my measure tool here. I need to get the angle measurement. I need to click on the points in a 1, 2, 3 order, where the second point I click on, the middle point, is the vertex point, and I need to go in a clockwise rotation. So I click C, A, B, and I get a measure here of, it's said to be 43 degrees. Again, that is subject to change as I rotate this around, maybe stopping here at close to a 90. There's my 90. Okay, I lost it, of course. When it hits 90 exactly, you'll get the box there to indicate that that is a right angle. Okay, all right, I can go into obtuse angles and then all the way over to a straight angle, and illustrating that really you can have angles in excess of 180 degrees if you can envision that. Okay, not to be concerned about that right now. Okay, now we showed you in class angle addition. Okay, we want to show you in this instance we want to show you the angle bisector. So again, we have a tool over here that is going to afford us to do angle bisector. We click on it. Okay, again, it says select the 3 points or 2 lines. Okay, so select the points in succession, C, A, B, and there is my angle bisector. To illustrate that this is an angle bisector, let me put a point on that angle bisector and measure each of the new angles that have been formed. Okay, let me do that again. Okay, a point on, unless I chose the wrong one, point on the object. Okay, and try it again one more time. Okay, point on the object, select the object, and there's my point D on the object. Let's do an angle measurement. The angle measure DAB. I'm going to kind of pull on these angles. So there's my overall angle. I'm going to put that outside, and my 27-degree angle I'm going to put in there. And then I'm going to look at the measure of the angle CAD. Okay, so I'm going to measure that angle, CAD. That angle, as you can see, is the same as the top angle there. Okay, and in fact, if I try to resize the angle, then I'm resizing the angle, but notice that, of course, what happens is I still have the 2 congruent angles, okay, that have been formed by the angle bisector. And of course, if I move this so that the overall angle is 90, and I can't quite get there, but that's close enough. Okay, if I move it to 90, then of course we can and should agree that what we have are 2 angles that are congruent, and let's get it there. It's close enough. Okay, two angles that are congruent and complementary since they add up to 90. Okay? Alright, now let's do the exercise we did in class. Okay, and showing you the, I think what we'll do is we'll do this as another video since this one got a little too long. So in the next video we'll come back and we'll do the in-center.